ALICE stands for a Large Ion Collider Experiment at the Large Hadron Collider at CERN in Geneva, Switzerland. My name is John Harris. I'm a physicist. I'm a professor of physics here at Yale. I'm the national coordinator here in the US for the ALICE experiment. The goal of the Large Hadron Collider with heavy ions, and namely the ALICE experiment in particular, is to recreate conditions that existed some 10 microseconds after the Big Bang, when all of the matter in the universe was in the form of very hot soup of quarks and gluons. Quarks and gluons are part of the fundamental constituents of matter. There are different types of quarks that make up what we see as particles, and gluons hold the quarks together, which are the constituents of the particles that we know. We'd like to study this at such early times to try and understand how the universe evolved, and we basically understand what happened since that time, some 10 microseconds after the Big Bang, when later on nuclei and atoms and galaxies and solar systems were formed. But as we go backwards towards the Big Bang in time, it is much more difficult to know, and so we're trying to establish what were the conditions and what really took place in those first few microseconds. Why are we colliding heavy ions together? Well, heavy ions are heavy nuclei, and we're colliding specifically lead at very, very near the speed of light. So they're traveling very fast with tremendous amount of energy. And so all this energy that they're taking with them when they collide is being converted into making particles and antiparticles. So there's matter and antimatter being made out of energy. And so we have lots of particles coming out, and once we study those particles, we kind of reconstruct back in time, back to when the collision took place, and try to get the temperature and the properties of the matter that existed at that very initial part of the collision. The Large Hadron Collider started operating just this year for physics, and at the very highest energies ever started colliding lead nuclei, heavy ions as we call them, in the beginning of November, and it'll operate in this mode for 1 month. Already, after just 2 weeks of operation with lead ions, we've started to analyze the data. We're already starting to publish papers. It's an extremely exciting time. This doesn't happen often, and they've started a new machine, and we've entered a new era colliding these heavy nuclei at these high energies, and we expect to have some discoveries over the next 5-10 years, maybe even only the next year or two.